Imagine if you could see past the present. Not to pick the lottery numbers in advance, or a horse before it wins at the track. But what if your body had a kind of subconscious early warning system that could slow you down or speed you up to avoid danger? Now, I know that sounds ridiculous, but here in Palo Alto, Dr. Ed May has done experiments that suggest people's bodies can sense what's going to happen to them, even though they don't know it. Now, I'm kind of skeptical, but I'm going to try it anyway. Dr. May?
Yes.
Jay Ingram.
Ed May, glad to meet you. Come on in.
Thank you. Edwin May's clients have included the U.S. Army and the CIA, two groups that certainly would love to know what's going to happen before it does.
Why don't you have a seat, Jay, and I'll give you a brief thumbnail of what we're doing.
Give me the preamble.
Okay.
I know it's about the future and maybe predicting it.
Well, it turns out we've been doing this similar kinds of experiment for about 2.5 years. And what we've discovered is something rather amazing. That is that our bodies, the nervous system, our part of our nervous system that runs our bodies without having to pay attention to it, appears to be slightly predictive of the future. And so we fill this cup like that.
Dr. May uses electrodes hooked up to a computer to record skin conductance. He says the changes picked up by his instruments are a good indication of subtle reactions in our bodies.
Hopefully, we'd like you to be as calm and relaxed as possible. See that? That's called a startle. Did you jump out of your skin?
Actually, you know, I didn't. Oh, see, that's an important point. I didn't feel as if I jumped out of my skin.
That's right, but boy, you saw it here.
Can sure see it. Now, the key to the experiment is to record the timing of my reaction. If I reacted after the hand clap, I was just startled. But if I reacted before Dr. May clapped his hands, I predicted the future.
I'll give you a sample sound.
The real experiment takes about 26 minutes, based around a series of sounds randomly generated by computer.
About once every 45 seconds, plus or minus 20 seconds or so you can't outguess it, it's going to flip a coin, and if that coin lands heads, you'll get 1 second of very loud noise in your ears. If that coin lands tails, you'll get 1 second of silence. And so at the end of the time, there'll be roughly 15 sounds and 15 silences randomly intermixed. Right. And what we look at is what your body has been doing prior to the sound compared to prior to no sound. Let me put these earphones on you. Ready?
Mm-hmm.
Okay, Jay.
So with my headphones on, I'm ready to predict the future. Dr. May fires up the computer, and I sit back and try to relax for the next half hour.
Jay, you awake? You awake?
Yeah.
Okay.
Barely.
Just barely. You can sleep till I'll take these off for you. Just relax a minute.
Once I finally got comfortable, I was set.
Well, what was it like for you?
Well, I can honestly tell you,
yeah,
I had no clue when those were coming.
Well, that's kind of what everybody we know reports.
Yeah, it's because some of them seemed enormously far apart. Some seemed to follow right on top of each other.
Right. So that's the whole idea of randomness.
There was no way that I could ever kind of get a sense of timing and then be able to predict.
Okay, so let's do an analysis.
The computer has plotted my reactions to the sounds on a timeline. And at first glance, there's nothing out of the ordinary. My reactions for the first while seem to follow after the sound.
Mm-hmm. This is really beautiful, Jay.
But then Dr. May spots this example.
0 is, again, in time when we...
The coin flip?
When in this case, we actually had a sound for this particular stimulus. Mm-hmm. And here's 1, 2, 3, 3.5 seconds before. Don't worry about anything on here except this blue curve. And you can see, even at this point is when the decision was made, when the coin was flipped. But your body, look at here, your body was already responding in a very large way compared to, let's pick one where you didn't have anything, just as a comparison. Nothing was going on. It was just relaxing before a control. So compare that picture before a control where nothing was happening. Your body didn't have anything to prepare itself for. Compared to this, where, my gosh, your body was responding in a very definitive,
pre-responding.
Pre-responding. Your body was peeking slightly into the future and preparing you for a future surprise. In this case, a loud sound, not a saber-toothed tiger hiding outside the cave.
Boy, that's amazing. Okay, I'm going to ask you some skeptical questions.
Please do.
You've shown me one example where that worked. There are other ones that you've shown me where it didn't work.
That's great.
So, does that really mean anything if it's quite, if it's not consistent?
In a single run like this, where we only had 15 sounds roughly and 15 controls,
Right.
the statistical answer is I would have to say no. A single run like this doesn't have any meaning. It's certainly suggestive, but we've done this experiment now with maybe a total of different laboratories, maybe 400 people. And when you stand back and look at all that data together, it is statistically incontrovertible that something interesting is going on. As scientists, we're charged with the responsibility to make sure we haven't overlooked something and that there's some sort of an artifact.
Right.
So far, our colleagues at major universities around the world, as well as our colleagues in research parapsychology, have yet to identify a potential flaw.
Dr. May also points out that not everybody is able to peek into the future. Only about 40% of his subjects show a pre-response.
It's like other human skills. Not everybody can run a 4-minute mile, and not everybody can high jump 7 feet in the air, things of that nature. So the fact that 40% of people could actually do this, that's astounding.
And while he doesn't fully understand why some people have this ability, he says it's certainly worth more investigation. Why does the prediction seem to center on about 3.5 seconds before the sound rather than something more or less?
That's about the time it takes for your whole autonomic nervous system to get cranked up and ready to run or fight as you are presented with a surprise. So it makes sense. I can't guarantee that's the answer, but it certainly makes sense, and we need further research to determine why that 3.5 and not 4 is the answer.
But if it's for survival, 3.5 is better than, say, a minute or a tenth of a second?
Sure. If someone's about to shoot you, knowing for sure that you're about to have a bullet hit your brain a millisecond or a thousandth of a second in advance is not useful to you at all. And if you have a week in advance, you won't have any idea whether I should worry about walking out on the street or going to the supermarket next week. So somewhere between that range, and it's a qualitative discussion, that about 3.5, maybe 5 seconds, that period of time would make sense. Now we have a challenging task ahead of us to figure out why it is 3.5.
And no one can predict the results of that research.